Imagine your organization is scaling the AI operations, and your managers are concerned about energy costs and environmental impact. As an IT expert, you can propose things like green AI approach that incorporates AI accelerators, things like GPUs and TPUs, for efficiency, along with smart power management and optimized cooling systems in the data center. This strategy delivers high performance while reducing the carbon footprint, making it both sustainable and cost effective. This is like a win-win-win. Okay, win for the AI, win for the environment, and for your career. Let's see how this can happen. AI is transforming industries for sure, but there is a growing awareness around something that is called green AI. It's not the color green, but it has to do with the environment. That actually focuses on making AI more energy efficient and environmentally friendly. By promoting sustainable practices, these guys right here, green AI ensures that resources are used wisely, supporting the transition to circular economy. It helps with also climate changes or climate change mitigation by improving energy management systems and reducing the overall emissions. Green AI is also key for energy optimization right over here, especially in areas like smart buildings, for example, where it can cut down on unnecessary energy use and carbon emission. Environmental monitoring, on the other hand, is another benefit when green AI enables real-time monitoring of ecosystems, providing data to improve sustainable efforts. And by reducing energy consumption, it leads to cost reduction, of course. On the other hand, we have red AI, which takes a different approach. It gives precedence to performance and accuracy, often using massive computational power to achieve faster and more precise results. While red AI delivers cutting-edge models, its very heavy energy consumption raises concerns about environmental impact. The balance between green AI and red AI is what we need. AI can definitely help businesses cut operational costs, but let's just be honest, it can also be pretty expensive to get started. There are a lot of factors that drive up the cost, like the infrastructure you need, for example, or the energy it consumes, and the time spent on training the AI models. Plus, don't forget that there is also cost of hiring skilled professionals and experts. With all that in mind, it's really important to think about how you can minimize expenses before jumping into an AI strategy. Typically, AI costs fall into 5 categories, as you can see them right over here: data, compute, development, utilization, and maintenance. When organizations decide that they want to adapt the AI solutions, they often overlook the time and efforts needed to acquire and process high-quality data. Raw data need to be cleaned. That's the main keyword here. We need to clean this data. It needs to be cleaned, whether you're just going to be cleaning it manually or automatically, or just maybe a mix of both methods, manual and automatic at the same time. Clean, reliable data is key for fine-tuning models, improving accuracy, boosting efficiency, and cutting costs. And here are some examples of how we can actually clean the data: by clean formatting, remove irrelevant data, and removing duplications. And you can see the list goes on. These are very helpful when it comes to cleaning your data. Let's talk about another aspect that you need to consider when designing a sustainable AI model: AI accelerators. Oh, what's that? AI accelerators are specialized hardware designed to speed up and improve the efficiency of AI tasks, especially in machine learning and deep learning. They are built to handle the heavy lifting that AI models require much faster than the traditional CPUs. You can have a compute node that has a CPU and also the other processor that will take care of your AI task much better. For example, the GPU this guy was originally created for gaming and graphics, but look at it now. It has faster processing and it's better for AI infrastructure, whereas Tensor, okay, TPUs, tensor processing units, where Google actually created TPUs to boost machine learning, especially for TensorFlow. And the N, neural processing units. They process neural networks fast, handling tasks like image recognition and natural language processing. They can commonly be found in cell phones and self-driving cars as well. And V for vision. Oh, okay, well, the vision processing units, what do? They are built for computer vision tasks, such as surveillance and autonomous vehicles. They're often found in drones and inspection systems. And let's not forget the very famous ASICs, application-specific integrated circuits. They are custom-made chips designed for specific tasks, and they cannot just do any other task than what they've been manufactured for. They've been there forever. It's nothing new here. ASICs were there forever. However, the competitor, the FPGA, stands for Field Programmable Gate Arrays. Well, field programmable. Unlike ASICs, they can be programmed after manufacturing, allowing flexibility for different tasks and improved performance. So the benefits of using this specific AI accelerator for your AI model can be a lot. Efficiency, accuracy, speed, scalability, flexibility, and cost reduction if you choose the right processor for your AI infrastructure. Will you believe me if I tell you that training AI models consume a staggering amount of energy? And here's the kicker. Despite promises to reduce carbon footprints, many tech companies have actually seen theirs grow. Fun fact, that is actually a study at the same time. They found that just one AI model training produces more carbon dioxide, CO2, than the average 55-year-old has in his entire life. Okay, that's the solution. What's the solution? Well, companies need to step up and focus on smarter strategies like optimizing hardware, boosting software efficiency, and managing data centers more effectively. Okay, well, tell me more about it. First of all, hardware optimization. To optimize hardware, make sure you use efficient and less power-consuming hardware. Examples, you have it. Well, ASIC, TPUs, GPUs, all the PUs other than the CPU are welcomed here. And also, let's not forget this guy here, the CRAM, the computational RAM, and the DVFS. This guy, what about it? Well, here's the thing. Power capping limits energy use during peak times, while DVFS, what's the DVFS? It's the dynamic voltage and frequency scaling, which dynamically adjusts the voltage and frequency of processors based on current workload. By doing this, it reduces the power consumption. While if we talk about software efficiency here, AI software efficiency focuses more on doing more with less computational power. And the kick is optimizing the AI model with a bunch of techniques, such as the ones you see over here: quantization, model pruning, and knowledge distillation. What are these? Quantization, which is reducing precision, like for example, using 8-bit instead of 32-bit to save your resources. And then model pruning. What about it? Reducing the precision was one thing, but then you have to cut out unused neural networks. And this is some kind of shrinking the model without losing performance. And let's not forget distillation, knowledge distillation. You're just diluting or minimizing the effect of training. How? By training smaller student models to mimic a larger one. Very smart. Speaking of smart, well, managing your data center in a smart way is something that you also need to consider. It's not just about checking the power bill. It's about constantly monitoring energy use at the device level and adjusting based on AI workloads. And here's the thing. Where your energy comes from matters just as much as how much you use. Let's not forget these different methods that you need to look at: the lighting, the electrical infrastructure and support, IT equipment, and HVAC. Oh, what about it? HVAC. heating, ventilation, and air conditioning. It's actually a technology used to control the temperature, humidity, and air quality in indoor environment, ensuring comfortable and air circulation. You need to also take care of that and provide the most power efficient cooling method. And there are lots of cooling mechanisms and methods here. We have free cooling, air cooling, evaporative, and liquid cooling. No single approach can provide a complete solution, but by combining multiple strategies, you can significantly reduce energy usage and reach optimum data center management. Summary time. Green AI focuses on energy efficiency while red AI deals with performance, but it uses more power. A balance is essential for sustainable AI infrastructure. Implementing AI is expensive, driven by infrastructure, energy, and skilled labor, with optimization focused on several factors such as data, compute, development, use, and maintenance. TPUs, NPUs, and also GPUs speed up the AI task and improve efficiency versus or compared to CPUs. Power and cooling are very important. Optimizing hardware and software and managing power and cooling can reduce the carbon footprint. Monitoring energy use, using clean power, and employing efficient cooling methods are key to managing data centers' energy consumption. I hope that this was informative, and I'd like to thank you for viewing.